Good morning, everyone. I want to begin by thanking Nathaniel and Anna and their colleagues on the project for inviting me. It was such an enticing invitation, and I think partly because I'm working on a new book and I've been working on ideas about the cloud and cloud computing. So the sense of a focus on the stream then really got me thinking about the relation between data streams and clouds. And exactly how we could think this relation. So I suppose if I had to put my 30 minutes or so into a single line, I would say that what I want to try and do is explain how it is that data streams of many kinds, as I want to suggest, condense in the cloud. So I want to say that this is a process of the condensing of a volume of data, and that actually this does have, I think, quite significant implications for how we think about the volume of data or big data, because if we're saying it's about condensation or about bringing to attention droplets of things of interest to act upon, then perhaps the volume itself is not the important thing, but the processes of calculation that take place in order to make some things visible. So I want to begin in what might seem like a very curious place, and it's really been driven by my interest in physics and in why it is in my empirical work, interviewing and observing the process of writing software, that so many of those people have their background in physics. So I want to begin with a very particular physicist, and that's Charles Wilson. In his Nobel lecture of 1927, he described the cloud chamber experiments he'd conducted from the late 19th century, and how these were unexpectedly to transform the capacities of modern physics into the 20th century. So Wilson had witnessed at the end of the 19th century, from the observatory at the summit of Ben Nevis, what he described as wonderful optical phenomena of the formation of clouds. So he was very inspired by what he'd seen, and he went on to try to, as he describes it, imitate the formation of clouds in the laboratory. So for Wilson, we might say that the aim was to reproduce in science the process of the formation of clouds in nature, and by doing this to advance a kind of classification of cloud forms, maybe even a kind of relational database of cloud forms. So for Wilson, it was about observation, reproduction in the laboratory, and classification. But when Wilson began to experiment and develop his cloud chamber apparatus, what he discovered was an unanticipated potential to see something we might say would otherwise not have been perceptible, phenomena beyond direct human observability. So in contrast with the telescopes he'd used in the observatory, where his optical instruments had brought objects into sight, he moved to devise a quite different kind of instrument to bring something into perception that could precisely never be seen, the movement of particles. So experimenting with supersaturation in temperature and the expansion of gas in his chambers, Wilson reflected that he'd come across something which promised to be of more interest than the optical phenomena I'd intended to study. We had a means, he said, of making visible and counting individual atoms in an exceptional condition. So what Wilson's cloud chamber made possible for the 20th century study around the world of particle physics was the ability to photograph and perceive the movement of subatomic particles. We might say the stream of a subatomic particle. So while these charged particles could not be directly observed, their traces and trajectories of motion, their movement or their stream, appeared via the cloud tracks condensing on the nuclei. You can see there Wilson's 1912, the very famous photograph on the Atlas of Cloud Chamber Images. So what I want to say is that the device of the cloud chamber, which was conceived initially for the human observation of these processes, became something else. It became a technique for rendering perceptible movement beyond thresholds of observation. As the historian of science, Peter Gallison, has put it so well, after the cloud chamber, the subatomic world was rendered visualizable. Now, almost exactly 1 century on, from Wilson's 1911 cloud chamber images, the idea of the cloud once more seems to be describing the advent of processes at scales that seem to exceed our capacities to see them or to understand them. Indeed, the cloud, of course, in cloud computing is widely held to derive from the mapping of the infrastructure of the internet, where the figurative cloud stands for the complexity of the internet. Now, I want to suggest that in the 21st century, cloud computing promises to have effects on our world analogous to the effects of the cloud chamber on 20th century science. So in February last year, 2015, 17 US intelligence agencies, including, of course, Homeland Security Department, NSA, National Geospatial Intelligence Agency, US Army, CIA, and so on, launched what they called the EyeSight program. Here again, I want to suggest the beautiful sight, the promise of pictures of a data stream otherwise unavailable to the senses. So EyeSight is a $600 million cloud computing contract, of course, with Amazon Web Services. And EyeSight, it was promised by James Clapper, the US Director of National Intelligence, would, he said, allow the government to discover, analyse and share critical data in an era of seemingly infinite data. So not big data, but infinite data. And then to return to this question of the discovery and the analysis later. But suffice to say that the cloud's promise of infinite data has, I think, extended what I have called the politics of possibility, the capacity to act upon a horizon of future possibilities indifferent to the strict calculation of their likelihood or probability. So the data of these agencies, I'm sure you can imagine, it includes the streams from sensors, satellites, UAVs, open source social media, image files, the sentiment analysis of text data, voice, video, and so on. As the CIA's Chief Intelligence Officer Douglas Wolfe expressed his hopes at the launch of the EyeSight program, we hope to get speed and scale out of the cloud so that we can maximize automated security. So might we say that the cloud makes it possible to act upon the data stream? The cloud is the condition of possibility for action on the data stream. And if it is, then as a geographer, I guess my first thought is, what is the geography of the cloud in cloud computing? If the cloud is becoming ever more closely intertwined with security and intelligence, with border controls, with drone strikes and sovereign decisions of many kinds, then what is the nature of these practices of data gathering, analysing and knowing? So what I want to try to do is to address the calculative form of the cloud and ask how it transforms the character of what or who can be sensed and perceived in our world. Rather like Svetlana Alpers in her discussion of history of the cloud chamber has said, she says she's interested in the character of an instrument and the effects produced with it. And I guess that's what I'm interested in here, the character of the instruments of cloud computing and in their effects in the world. Now, with this audience, I don't think I need to explain the architecture of the cloud, but I think the significance here, and moving quickly here, is perhaps in what Benjamin Bratton recently, in his new book, The Stack, has described as this kind of layering of the stack. And I think it's just two things are important here. One is that we shouldn't get too carried away with this as something new. So you can see there from his famous lecture in 1961, John McCarthy at MIT, imagining a future where computing may someday be organised as a public utility. So this sense of a kind of migration of computing functions to the level of shared provision and beyond the server and the PC is something actually with a much longer history. For me, and the thing I want to focus on today is really this applications layer. So I want to say that the emphasis needs to be on what the significance is of cloud-based applications and perhaps even a business model that's based around cloud-based applications. So the cloud does materialize, of course. It is actualized in the infrastructures of, as we know, vast data centers or so-called server farms. And here, in a very limited computer science way, geography is said to matter. So when the computer scientists ask, where is the cloud, what they call the geography questions tend to be about the data centers that they think underlie the clouds, their physical location, their resources, and their jurisdiction. So we might think about the particular tax arrangements in Georgia and the location of Google's new data center there. Or we might think of the former missile bunker in Sweden that's now being used by ISP Bahnhof in terms of the capacity for cooling beneath the city and the kind of geographical location of that site. Or we might think of Sun Microsystems' Project Black Box, in which the server becomes part of a kind of shipping container sense of a geography of logistics. This actually, the intellectual property for this is now owned by Google with their ocean-based data center. Now, I want to propose that we think about this paradigm as Cloud 1, or as a geography of cloud forms. Cloud 1 is concerned with the identification and spatial location of the data centers where the cloud is thought to materialize. And it's this imagination of the cloud that I think has dominated political, even geopolitical debate. So, for example, following the Snowden disclosures of the extent of US authorities' access to cloud data, much discussion in the European Union about re-territorializing those data centers within European territory. Canadian legal changes, legislative changes that require public data to be kept on Canadian soil and not to be put on US data centers. So we might call this, I think UC Parika in his book on the geology of media has talked about a territorial impulse, which I want to describe as part of Cloud 1. Similarly, when the UK Foreign Secretary Philip Hammond appeared before the Joint Intelligence and Security Committee in the UK after the Snowden disclosures, he was asked questions about the cloud, and I want you can see the full text online. It's really quite something. I mean, considering he is the final sovereign authority on interception of the data stream, he had really no adequate answer to the questions about the cloud. He was asked, what about cloud storage, where no other person is involved, Minister? It might be my decision to upload photographs to Dropbox. Would these communications be regarded as external because they are on US servers? He couldn't answer. He said, well, my colleagues, yes, actually, I'm advised if the server is overseas, they will be regarded as external. So, the idea that this might actually be a question of sovereign authority, I think, to an extent, these cloud geographies, I want to say, overflow and exceed the criteria and categories of bureaucracy and law. So, in a sense, Cloud 1 has become about where the data is. So what's come to be at stake here politically has been a kind of struggle to wrest the cloud back into an intelligible form, a demand to make the cloud intelligible. Even among the critical accounts, we can see here the artist and geographer Trevor Paglen in his work. He considers the cloud to be a metaphor that obfuscates and obscures the material power of what he calls the surveillance state. And his response is to try to bring back the cloud into a line of human sight. So his ghostly images of the NSA and the NGA's data centers using helicopters and using telescopic instruments of astronomy to try to bring those practices into vision. So that Cloud 1, I want to say, is much more akin to what Wilson was doing when he was trying to bring the cloud into sight. So as Paglen accounts for his work, he says, my intention is to expand the visual vocabulary we use to see the US intelligence community. He says, if we look in the right places at the right times, we can begin to glimpse the vast intelligence infrastructure. So to expand the visual vocabulary and see a vast infrastructure, to bring into vision this thing which otherwise would be apparently obfuscated by the cloud. But what would be the right places to look? What would be, thinking about art historian Jonathan Crary and his very careful histories of vision and visuality, what would be the appropriate ways of seeing these things? If the cloud infrastructure, as Paglen suggests, is somewhere in this glimmering vision of the NSA, could it also be in much more ordinary sites from my fieldwork? Could the right place be to look in one small piece of a cluster algorithm which found its way into an electronic borders system for identifying high-risk people when they arrive? Could that be the right site? Could a rather dull building on Pentonville Road in London, where a group of physics graduates are writing new algorithms for so-called smart borders, could that be the right place to look? How would we know where these places are? My point is that this desire to open the black box of the infrastructure, to expand the visual vocabulary, risks replaying the paradigm of observation. So Cloud 1 is asking, where is it? What type is it? Can we map it? Can we recognize it? It sustains the idea that we can have a more beautiful sight, a means of seeing more clearly, of rendering coherent and intelligible. So the telescope and the camera that Paglen brings to the scene of data deployment belongs to a particular history of observation, one that Donna Haraway described it as long ago as 1988 as one of visualizing technologies without apparent limit. So I want to suggest that Cloud 1, to an extent, misunderstands the algorithmic work of the cloud. And it's perhaps not capable of doing what Haraway suggested all those years ago we should do, which is think about, she said, partial and indeterminate lines of sight, systems with partial ways of organising worlds. So rather than bringing something into our visualisation as complete, thinking about its fragility and thinking about its partiality. So Cloud 2, I want to describe as being a cloud analytic. Here the cloud is a bundle of techniques acting upon the threshold of perceptibility itself. So in the relation which Nate described between the stream and consciousness, I want to suggest that what the analytics of the cloud do is allow for what Henri Bergson described as a kind of perceptual cut in movement, a kind of, what he calls an organ of perception that allows those things to be seen. Peter Gallison reminds us that in the cloud chamber, we do not actually see things. What we do see has a close relation to them. So we observe the things in relation, the traces and the trajectories and the pathways, and not the thing itself. So what he calls an almost seeing of otherwise subvisible entities. So then to say the cloud obfuscates is to miss the point somewhat. The cloud is not an obfuscation. Far from it. Like the cloud chamber of the 20th century, contemporary cloud computing is about rendering perceptible and actionable, almost seeing, that which would otherwise be beyond the threshold of human vision. So then the cloud chamber, with people like Karen Barad, for example, would be not an obfuscation at all, but part of the condition of intelligibility, that these arrangements are required in order to render the stream intelligible. So what happens if we reimagine cloud as a mode of analysis or calculation, even as a form of reasoning? Returning to the site of the iSight cloud program, what perceptions of the world become possible with the algorithmic instruments that gather in cloud space? So what we did empirically, what we've done is we've followed the applications that are available through the iSight program to see their kind of genesis and try and trace their genealogy. So describing the digital reasoning software, which is supplied as an app on iSight, for example, its designers describe how initially these algorithms were used in the financial sector. So they say, they were written originally to look at terabytes of emails per day to detect hints of insider trading. So there's a sense that the algorithm can travel and move across domains. So the CEO of digital reasoning says that what this technique is doing is changing the aperture of observation. Machine learning algorithms that he describes, he says they sift through sensor data and social media chatter, bringing structure to human language as an intelligence source. So changing the aperture of observation, let me agree peculiarly with this vendor of systems for Homeland Security and say, yes, the aperture of observation is changing, but not in such a way that the promise of a complete picture is delivered onto the screen of the analyst. Instead, incomplete fragments are surfaced and made actionable across time and space. So digital reasoning software analyses across data forms indifferent to their type, image files from the NGA, voice from Skype, sentiment analysis of text from Facebook, for example. So in this sense, perhaps this is not about the conventions of joining the dots that we've thought about perhaps, as much as a decade ago, but perhaps not joining the dots, but combining streams, making it possible to combine streams. So with cloud infrastructure too, where I'm interested in the analytic, what can be perceived and claimed about the world changes, the aperture of almost seeing, if you like. As one analyst put it to us in an interview, it allows us to say, he said, correlation is enough. Correlation is enough. We can stop looking for models, throw the data at the biggest clusters the world has ever seen, and let algorithms find the patterns. Now, it's a big claim, it's a grand claim, and when we follow it through, we know that it's not a claim that's achieved. But nonetheless, it's a claim that has a certain power, at least in the areas that I'm looking at around borders and security. So in the final 10 minutes or so, I want to say 3 things about this correlative form of cloud reasoning and why I think it has significance. And I want to talk briefly about condensing traces, so this process of condensing or condensation. I want to talk about discovering patterns, so the discovery, and archiving futures, so what happens to the archive in relation to the cloud. So first, what I want to call condensing traces. These are images from a famous atlas of cloud chamber images. The significance of the atlas was really to allow the photographs to circulate so that physicists working in other laboratories in other parts of the world would begin to be adept at identifying what had already been seen so that they might notice when something new happened in the cloud chamber. So the images themselves, I think, are interesting in terms of a kind of almost test data set or a kind of training data set for the observations of the physicists. So what I want to call condensing traces is a practice not primarily about bringing into vision, but rather engaging a sub-visible world. Inferring, importantly I think, inferring from the traces and trajectories that condense at indeterminate points. So recalling the analogy with the cloud chamber, by the mid-20th century, when Wilson's cloud chamber was being widely used in subatomic physics, the apparatus was described as allowing the study of the motion of particles from records of the drops condensing on their traces. So you can see there, the first image there is the famous one of the alpha track from thorium. So if we understand the infrastructure of the cloud chamber to be something like Karen Barard's understanding of a scientific apparatus, she says, these are the material conditions of possibility of mattering. They enact what matters and what is excluded from mattering. Well, then cloud computing, I want to say, is a kind of chamber or apparatus. It enacts what matters and is excluded from mattering. The person of interest at the border, the possible future protest event in a city, the chain of associations of no-fly lists, blacklists, even kill lists, like the beaded chains of condensed data in the cloud chamber, are making action possible. So we might say then that it's the condensation of the volume and the reduction of the volume. That's the important step here. So for example, in one interview we did with the cognitive computing designers for eyesight, they said, we use this to identify civil events unfolding, such as political unrest, violence, or anything that may be atypical. Anything that may be atypical. So, condensing traces. Second, discovering patterns. Describing the knowledge discovery software that they supply to the eyesight program, Radiant Computing speak of uncovering answers to questions the analysts don't already know. So in contrast to a deductive form of reasoning by hypothesis testing, here what Luciana Parisi has written about beautifully, I think, in her book on contagious architecture, what she describes as abduction, abductive logic, is generating the queries. So in a sense, what one will ask of the data becomes a product of the patterns and clusters in that data. So perhaps maybe we can think about the stream as generative in that sense. So in Cloud 2, at least in part, the rules generated by the rules within the analytics surfaces what comes to matter, I think, on the screen of the border guard or the intelligence analyst or the officer looking for financial fraud, for example, at his or her desk. So just to give you another example of that, the designers of the T-Digest algorithm described to us, they said, small fluctuations occur in the event stream. So looking at Twitter feeds, for example, they say, well, small fluctuations occur in the event stream. And then they say, our model can adjust its view of normal accordingly. So the data stream used to adjust the view of normal. And the particle physicists were similarly inferring from the patterns of previously unseen, unknown particles. The central problem of interpreting the images, Wilson described, was recognizing the patterns involved in a particular event. So the almost seeing of the cloud chamber infers from something closely related to the event. So the event itself could be a drone strike, the event could be a protest in a city street, but the inference is taking place in relation to something that is closely allied to it, a movement or a stream in relation to the event. The almost seeing of cloud-based analytics emphasizes the detection of patterns in a similar way to the cloud chamber, so as then to better recognize the hitherto unknown, the thing that is not yet seen. And I think for me this is significant predominantly because it's a challenge to say to the response that the thing that is damaged here is, say, personal privacy or some kind of notion of a body of rights that we're protecting. And it says actually one of the things that's damaged here is the openness of a possible future, that this thing in close relation to the event may play out differently, but nonetheless it will be acted upon preemptively. And so, and this is the final aspect of this I want to talk about, the important thing then will be to think about what sort of harm is done in terms of the future. The image there, building threat analyst centaurs, was from part of our field work where we were observing the pitches that were made by some of these software providers to security analysts. And the threat analyst centaur symbolises a kind of combination between human capacities to detect patterns and infer things and the machine learning aspects of the use of algorithms to develop those. So the threat analyst centaur. So archiving the future. When Amazon Web Services supply cloud to corporations and to governments, they very helpfully supply what they describe as an app store, so that the analysts can select the tools they want and pay for what they use. So there is, of course, a kind of desiring and wanting consumer in this app interface. And it was described in relation to the US intelligence agency's use of eyesight as like the familiar Apple iTunes. So I haven't really worked on this yet, but I think it's interesting, this relationship between our kind of cultural embodiment of streaming, like music streaming, and the sense of a security apparatus that might itself wish to act in and through the stream. So, like the familiar Apple iTunes, the streaming of music and the streaming, it seems, of intelligence. Imagine then the Homeland Security Department, NSA, or US Air Force analyst browsing the eyesight apps more. What might they find? Well, one of the things they would find is the recorded future app to run analytics across the join of public-private cloud. Entirely by chance, today's Guardian has an article which is all about how MI5, MI6 and GCHQ have now responded to the request to show how bulk data is being mined. The story has been presented as being about the bulk data, but in the text, I think, is the most significant point, which is about how data that might be considered traditional intelligence data, so signals intelligence, human intel and so on, is being combined, they're calling it fusion, with so-called open source streaming of Facebook, text, Twitter and so on. So that it's entirely by chance, but it speaks, I think, to what Recorded Future are promising here when they say we constantly scan open sources to identify entities and events, you can explore the past, present and predicted future of almost anything in a matter of seconds. So in this cloud geography, the analytic is all. The archived data in recorded future is infinitely tractable. Even the kind of dirty or muddy data in the calculation is rendered useful. The tracks themselves become the thing of interest. As Auret Halperin has written, I think, wonderfully in her new book, Beautiful Data, she says we need to remember that the archive is an active site for the execution of operations. It doesn't just store, it's an active site of operations. And I want to suggest this is the claim of cloud computing in the world, a kind of claim on the future, on the very nature of the archivable event. We recently did a series of interviews with some of these suppliers, and at one point they were asked by someone else in the room, well, do you store everything? And they said, no, we don't store everything, but we cache everything. And actually, last night at dinner, we had a long conversation about the difference between storing and caching. So, to conclude then, when I worked with some physicists at Durham, I asked them to show me their cloud chamber experiments. And initially I think they thought, why does this geographer, why is she interested in our cloud chamber? I wanted to show you this because it kind of shows you how normal the apparatus is and, the way that it works. And I expected that the thing of interest that we would be looking at would be the cloud tracks. I couldn't wait to see this for myself, these kind of wispy trajectories of particles or the movement of particles that had so captivated Wilson. But actually, we gathered around the scientific apparatus itself. There was disagreement among the physicists. What was the optimal point of cooling? Is thorium a useful radioactive material for the experiment, and so on? So what struck me then is it's the experimental apparatus that renders the thing perceptible. The physicists here were very similar to the physicists I've seen working on software, disagreeing about the best way to do it, to bring something to the surface. They agree, I think, with Isabel Stenger's noting that the cloud chamber is of the paradigm of experimentation, not observation, but experimentation. It brings something into being for us, whose existence would otherwise perhaps not quite be captured. And in the final minute, I want to just conclude by saying something about why this matters for our contemporary moment, when the cloud computing apparatus is bringing something into being, discovering associations and relations that would otherwise fall away. So, if cloud computing renders perceptible things which would not otherwise would be observed, then the algorithms for high-frequency trading or for real-time credit scoring or for traffic flow in smart cities or social media-based intelligence, these write data trajectories into being. The experimental techniques of these analytics are, I think, operating in excess of what we think of the kind of statistical norms of data gathering and prediction of the future. And I want to suggest that this has quite profound consequences. So the overwhelming response to the post-Snowden exposure of bulk data analysis has been a kind of juridical enshrining of the principle that no human eyes see it. So in a sense, I think the stream has, at least in the area of security, become a real domain of contestation, that no human eyes see the stream, that's something that only the algorithm could work upon. And so then, presumably, no privacy could be infringed, no racialized categories could be inscribed, or no errors of judgment made. We should then be apparently reassured that knowledge discovery is conducted by automatic process, not observed by human eyes. But as I think I've described, this misses the point dramatically. It's precisely in the sub-visible experimentation that a person or a thing of interest is brought to the surface of attention for action. So when someone or something is stopped or detained, when a bank account is frozen, when someone is targeted, when an asylum claim is approved or denied, to an extent, the apparatus decides who or what matters, in Barad's sense of the apparatus, playing a role in this decision, if we can think about it that way. So it makes particular political claims possible. It's already political. It's the condition of some of our contemporary politics. Here are the people and things with a link to terrorism, or here are the possible fraudulent asylum claims. Here are the optimal targets for the next drone strike, or here are the civil uprisings which will threaten the state next week. So as Cavendish, one of the protagonists in David Mitchell's brilliant novel Cloud Atlas, muses, he says, "What I wouldn't give for a map of the ever-constant ineffable, to possess an atlas of clouds." Programs such as eyesight make just such a dangerous promise, I think, to sovereign authorities, a kind of atlas of clouds for the ineffable, a condensed trace of the trajectories of our lives, one with another. Thank you.
I was just wondering if you could say a little bit more on the connection between the cloud chamber experiments and the contemporary computing idea of the cloud. Because it's got a very nice, very evocative, the connection you draw, but could you say a few more words on, is there a kind of a strict intellectual genealogy linking them, or are you sort of riffing on the connection in order to draw out connections in some way? Just wondering, what is the status of that connection?
Yeah. Thank you, that's a great question, Nathan. I guess it's a question about method. And I have thought about that a lot lately, because I know that's what I tend to do, juxtapose, what is juxtaposition as method. So in a sense, it's not to say that there's a kind of continuity in that kind of genealogy of physics, let's say, between the cloud chamber and contemporary cloud computing. What I was very struck by, though, is how in the discussions the physicists were having around the cloud chamber now, one of them said, "Oh, well, I'm also involved in the Large Hadron Collider." And you do, he said, you do realise that, strictly speaking, we could have discovered the Higgs boson using a cloud chamber, but it would have taken an inordinately long time. And then a huge kind of argument broke out among them around, precisely how particular sorts of arrangements of instruments would or would not make it possible to study something. And so it's not that there's a direct kind of intellectual tradition around this, I think, but it's more that I want to find a way of thinking about how does the apparatus of cloud computing, and perhaps specifically the sorts of applications that are being run in cloud computing, how does that allow particular things to surface to attention for action, things which would not otherwise be directly observable. And because so much of our critical and political response has been about observation, so even to say it's surveillant, I think I want to say it's not predominantly surveillant, and it's not predominantly of the paradigm of observation. Now, I think that's important to me to try and say, well, it's not about observation, it's about how something that's not observable is rendered actionable nonetheless. So to think about another moment in history where that problem seemed to be the nub of the issue, what sort of science is it where it's not about directly observing or using instruments to observe, but it's about being able to make scientific inferences based on something closely related to. And that's what I think I find so productive, is to sort of try and step back a little from this discussion about whether it is or is not ethical, for example, to mine bulk data, and say instead, well, look, why does the bulk matter? The bulk matters because it's part of the apparatus, right? The volume is just another piece of the chamber that's required. So the debate socially, societally, I think, has been about limiting access to that. And that's, because of this return, I suppose, to the idea of a liberal subject who, with claims to rights to privacy and so on. Important things, but I think, importantly, misunderstanding the technology and how the effects it has in the world. Yeah. We could talk about it some more.
I'm Alison Powell from the London School of Economics. And I wanted to follow up on that, and I wanted to talk a little bit more about the analytic, because I think this is something really important in your presentation, of the idea of moving to Cloud 2 as being about constructing meaning and, in fact, constructing reality through this observation. And I wanted to know if you had any further thoughts on what the consequences of this shift of power is, essentially, from a kind of shift of power which is about observing and collecting to analyzing and presenting back. Because I think in my own work I see this as well as something quite significant, that the calculative has now become a kind of source of power. And I wanted to know if you'd found in your fieldwork anything that would help us to understand the particular contours of this.
That's an excellent question, Alison. Thank you. I think, just to begin with what you said at the end there about the calculative becoming an important element of power, and of course, in a sense, this is nothing new at all, you know. And I do continually try and remind myself that we do have resources for thinking about these things. And so, you know, for example, Ian Hacking's book on you know, on the taming of chance, and on, you know, I mean, the careful attention to detail in these studies of how particular forms of calculation found certain sorts of political claims. So, you know, he studies very carefully the Belgian statistician Adolphe Quetelet and his capacity to, you know, the famous one is the measurement of the military chests, you know, and looking for, and it's about how the bell curve of norms becomes established as a way of understanding population. And I think, you know, for me, for the last few years or so, I've been interested in, well, what's happening to that sense of a bell curve or probabilistic sense of calculus. It's not so much that calculation becomes more important, but that I think that the mode of calculation itself is transforming in ways that really require us to think quite innovatively about how we respond. Because one thing we could say is, oh, well, we try to open the black box. You know, there's lots of discussion around, well, if we could just see inside those algorithms, and you know, I guess that's part of my problem with Cloud One, is this sense of the unveiling, that we might, in unveiling a particular algorithm, for example, or calling to account a particular software designer, that we might found ethics there. And I want to say that that's not quite so straightforward. And what strikes me in terms of you asked about fieldwork or about empirical observations, what strikes me is the politics that's already in it, in the design of it. And actually sometimes how incredibly sensitive the physics graduates or the data scientists are about their particular piece of a much bigger, you know, package, if you like, or parcel of analytics. And people, for example, expressing concern that something they designed for casino fraud has found its way into a particular electronic border system, and saying, that's not how I designed it, how can that be used? This is the test data set I used, this is how I verified it, how did it end up there? So this is a different sort of calling to account. It's not about identifying, you know, in which human subject the design of the thing rests, or in which algorithm. It's instead about identifying and thinking about those political, ethical moments that are already inside that sort of calculus in the threat centaur, I guess. A kind of post-human subject, yeah.
I'm Ramon Bloomberg from Goldsmiths College, the art department. I think that between Cloud 1 and Cloud 2, as you put it, there's also, I mean, you're hiding this kind of extensive, intensive kind of binary, whereas in Cloud 1 you have a sort of geographical, topographical rendering of the cloud, whereas I think what you're talking about in Cloud 2 is something more topological, where something like the liberal subject is actually highly questionable. Mm-hmm. And if that's the case, maybe you could take that up and go a bit further with it.
Probably not in 2 minutes. You should never ever ask a geographer about topography or topology if you want them to answer really briefly. But it's an excellent, brilliant question. And actually a colleague of mine, Lauren Martin, has a really beautiful essay just published, I think in Progress in Human Geography, about exactly this question of topology, and it's really an outstanding piece of work. So yes, I guess I've been thinking of it in terms of also the relation to territory. So what is it in this kind of territorial reflex to try to seek to relocate? So one of the things that I did was kind of try and trace through these struggles in Europe to try to reterritorialize the cloud, and kind of think about what sort of site of politics is that. And so I think you're right to an extent that there is this distinction then between topography and topology. But yeah, I mean, I've been thinking a lot lately also about, you know, and also triggered by this conference, thinking about the relationship between the data stream and what's often now described as the data lake. So because the significance apparently of the data lake is that the government or the corporation no longer needs to think only in terms of relational databases, nothing new of course in a sense, but that multiple forms of data can reside in the data lake and nonetheless be analysed despite their differences. So this relationship between the lake and the stream and the cloud, I guess, what am I trying to say here? That there's perhaps another relationship here which is about a capacity to calculate indifferent to the really profound doubts that exist in the science itself. And that's something else I'm trying to work on in this new project on ethics and algorithm, is to say, well, with people like Judith Butler, to say ethics, the moment of ethics begins where where we have some kind of principles and grounds on which we can stand, but precisely where we are confounded by what we see, right? Precisely where the fragments and partialities reside. And so to that extent, I suppose I want to escape some of these geography colleagues, but precisely what Nathaniel was saying at the start, which is about the significance of interdisciplinarity here, which is to say that we talk with and we work with physicists, computer scientists, ethicists, philosophers, artists, because the vocabulary, we don't quite have it. And so, the vocabulary of topography and topology may get us somewhere, but I think we probably need to explore more broadly for another way of thinking about it. Yeah.
Okay. Thank you so much, Louise.
Thank you.